Okay, hey, it is 2 o'clock, so we're just about to get started with the presentations. Is anyone still in the process of uploading your presentation? Okay, so we have a few hands. If you're able to upload it in like the next 30 seconds, I'm going to download everything that's there, and we'll essentially run through everything that's there at this time. And then afterwards, I'll go back and we can individually pick up ones that we missed or that got updated or something like that. But just to try to speed it up, I'm going to pull everything now and we'll just run through it in order. And plus that way you can kind of see where you are in the list and when your slot's coming up.
I don't have slides, I've just got my website.
Okay.
Bring up the website directly on here and show it off.
Yeah, as long as it's available on, yeah.
Cool.
Are you,
The JMAP.
yeah, okay. Are you ready? Maybe so I don't forget because you won't be in the list. I'll let you go first if that works.
Yeah.
Here, why don't you go ahead and pull it up?
Cool.
Okay. All right, is that basically what was supposed to pop up?
Yep. When it finishes loading these, it's a bit slow still. Okay. At the moment.
Okay. I'll leave it there, and I'm just going to make a couple announcements, and
cool.
Hopefully it's loaded
awesome.
by the time.
There we go.
And okay, so the way this is going to work is, we have that 3-minute time limit, as I mentioned. Rod here will be he'll be the timekeeper, and he'll give you kind of a nice, like, sort of 1-minute warning when you have only 1 minute. And then he'll give you a less nice, notification, I guess, when your time's up. If you don't wrap up in like 2 or 3 seconds, there'll be something even worse. So everyone start clapping. Okay, we can use that practice. That sounds good. So yeah, please do mind your time and realize we want to get through all these, and we have a lot of presentations, fortunately. So. Okay, so we'll get started. The first one is not slides, it's a website, and turn it over to you.
Cool. Thank you. This was not what I'd planned to do in the JMAP session today. I'm Bron. This is Topic Box, which is one of Fastmail's products that was built on top of JMAP, even before JMAP became a standard. And it's a mailing list product. So I've slurped in all of the IETF mailing lists. As you can see, there's quite a lot of them here. And showing what can be done with something like a powerful search, searching for anything by me on any of the mailing lists over the years. And we can scroll through here and see all the stuff I've done on every IETF mailing list. And you can search for anyone in there over the entire corpus of gigabytes of mail, and it's really, really fast. So this is JMAP as it can be used right now. I'll send a link to this around once we're happy that it's a little bit more stable and everyone can have a play with it. It slurps in slightly less than real time because it's pulling from IMAP. But this is what you can do with modern IMAP, modern email standards, IMAP replacement. Feel free to poke around on IETF topic box-scratch.com. That's all I've got. Anyone want me to search anything while we're here? Come along to this. Cool. Who's next?
Okay. I don't know. So let me get back my. Okay. So different than usual. It just seems by default it put things in reverse alphabetical order. So we're going to go backwards, which maybe is a good way. So I'm just going to go in order here. So the first one's going to be Yang, and then SCE, and so on. So you kind of have an idea when your slot is up. So Yang mediator, who's presenting that one? One other thing I should warn you, to advance the slides, use the left and right arrow as opposed to the up and down. If you up and down, it just kind of scrolls through the slides. Okay.
Good afternoon, everyone. Here's the description of our hackathon this time. And this time, our hackathon is about SV6 VPN YANG mediator. Oh, next.
Yeah, use the
here. Okay.
right.
Okay. So here is our hackathon plan. We have since when we developing the IETF service modeling and also the device model, we have facing this kind of problem here. On the left-hand side, there is the SDN controller architecture. Like in a lot of deployment, most SDN controllers needs to do like different vendor adapters to use different vendor native YANG to manage the whole network. But we also have some service provider have other requirements from them. Like they have their requirements. They don't want to like facing different vendor specific YANG modeling. So they are thinking maybe they can use IETF native YANG to manage all the devices and the network. And here's our proposal to this kind of problem. So we are proposing to use a mediator as a solution to migrate the vendor specific YANG to IETF YANG. Like in the right, that right now, like there's most vendors, they don't have implemented IETF YANG right now, but they can using the mediator as the proxy to the IETF YANG modeling. When managing the whole network, the SD-WAN controller in the network could only use like IETF SRv6 or BGP-SS to control the whole SRVPN services. Then when most when right now, at moment, they can only use vendor-specific YARN to develop the SRv6 function. Okay, thanks. So here is a topology, and this is our hexagon topology to control the whole network. And here's our.
Sorry, we're gonna have
Okay.
to cut you off.
Okay, thank you.
But I
Here's our demo results. Please join us if you like.
and will you be at the hack demo happy hour also?
Last time I'm on time.
Okay. Oh no worries. So I think you're going to demo it at the hack demo happy hour too. So that'd be great if people want more info. Let's go back. Yep, I believe you are. If I can figure out how to navigate back to where I want to be here. Okay. And yeah, so left and right.
The wonderful world of Chromebooks. Okay, so we did a bit of work on the SCE project today, with some congestion experience being a small extension to ECN that we've been working on this year. And this is covered by 2 drafts currently in the system, and also related work in a new queuing algorithm, which we hope will improve deployment. We wanted to test some of the more challenging traffic scenarios, according to RFC 5033, I think. And we decided to address some of the existing problems by revising our AQM. So the traffic scenarios we wanted to look at were bursty links that are often associated with Wi-Fi. These are typically problematic for high-fidelity ECN schemes. We first verified that this affects SCE as well, with the original marking scheme. We wanted to check bidirectional traffic on the asymmetric path, as that's another challenging scenario, and also competition between SCE and non-SCE traffic, as that's been raised on the mailing list as a concern. So, starting with the last point first, we know that in a single queue, SCE-enabled AQM, SCE gives way. With just plain ECN support in the AQM, SCE competes fairly in backwards compatibility mode. And with fair queuing, SCE also competes fairly. Now, we introduced cheap, nasty queuing to have minimal extra complexity over a plain FIFO, and that helps. And to address the bursty links on the path, we changed the SCE marking over to use CODL instead of a red plate algorithm. And this turns out to have helped rather a lot, increasing throughput from 7 to 40 megabits per second. We weren't really able to do very much with the bidirectional traffic, ran out of time. But we were able to make some progress with ACK-ECN and SCE compatibility with the help of Logan and Richard, who we've added to the team list. The work is mostly in our GitHub repository, and the link is in the slide. Thank you.
Okay, thank you very much. And next up would be IP Wave, it looks like. Great. And
okay, thank you.
Should be able to use right and left.
Okay. Hello. This is Jean-Paul Zhang from SKKU. This time, the IP working group, we demonstrate the IP Wave IP version 6 packet delivery over IETF106 OCB mode. So the hackathon plan, you can see the packet transmission over OCB mode. So vehicle environment case, DSLC, such as the wave communication is important. So we use the commercial Wi-Fi module working on 5.9 gigahertz DSRC band. Also, we demonstrate the IP106 neighbor discovery work in at the 11 OCB mode. Also, we can demonstrate the video the streaming service. So two drafts are relevant. So what got done on this hackathon project? So we fixed some compound error. So the kernel, the compilation from the another university, we tried to figure out the makefile error. Also, we enabled the DSRC band. Also, we enabled the web camera driver, so we can successfully compute the IP106 address and also UDP data delivery and also video data delivery. Okay, so this is the testing environment. So we over there we have two laptop computers. So we can install the Ubuntu Linux, and then we can enable the errors. The nowadays Qualcomm Wi-Fi module, so we can successfully deliver it. So this is the video the snapshot. We uploaded the video demonstration clip. Also, we can upload the manual for anybody who have interest in. You can install and test it. So this is the summary. So we learned how to configure how to IP106 delivery on top of a commercial Wi-Fi running 5.9 gigahertz. Okay. Also, during this hackathon, we showed current neighbor discovery IP wave is not complete. So IP wave working group we work on for neighbor discovery to enable automatically global IP address. Also, neighbor vehicle recognition will be done in near future. So we have a champion, me and Young-An Kim, Sungshin University, also post student. Okay, also Ryan side, you can get a video clip and manual, and also original contributor is Czech Technical University in Volkswagen. Thank you. Okay.
Okay. Next up, we have SRv6 mobile. Oh, yeah, sorry, I didn't catch it this time, but left and right to go backward.
Yes. Okay. Hello, everyone. This is Satoru presenting the IETF hackathon for SRv6 mobile user plane. I explained a little bit our hackathon plan to simplify the mobile network. Its idea is described in this slide. SRv6 mobile user plane DMM working group. So we implement mobile user plane requirement into one single layer, which is SRv6 IPv6 layer. SRv6 to be able to integrate mobile user plane to the underlying layers. So what got done is here we achieve 5G aware mobile user plane function. I'm not sure whether you already aware or not the 5G packet format. And that's user plane implemented on the VPP and P4 platform. And now is able to interwork with other SDO protocol, which is GTP-U in stateless manner. So GitHub repo is available for your review, and you can get Chrome and compare it to try that feature in your local environment. And the code has been submitted to BPP Gerrit to be reviewed. So one review is already verified by Jenkins, so that will be assure it's runnable on your environment as well. So what we run here, I think the BPP and the P4 is already a modular platform to make it easy to implement new function to be extensible. But we found another requirement to modularity for the platform to implement SR basic mobile function. So that would be a good feedback for the open source community. And other things is I and my colleague work on figure out a new function idea to be implemented. So this is wrap up. Our team member is Tetsuya Murakami, who is the first time to join the hackathon, and Kentaro Ebisawa, Pablo Camarillo, and Philip Berger. We also have the SCAPI code to generate the GTPU 5G aware packet, which is very new. And this is the lack of the point URL to show the P4 code, which is also available on the IETF Hackathon GitHub library. So please check out. Thank you.
Okay, so next up is ECA, and then after that we have PII. Great. Okay, forward and back. Thank you.
Hi guys, this is Michael from Huawei, and today this hackathon is about the implement one event condition action young data model, and this is our hack plan. We will verify and validate the feasibility of the young data model for policy-based event management to implement and test an event incident fault location and self-healing application in the network device. And we also implement and test and chain reaction of the coordinated event. And here is a reference. If you would like to read our document, please read it. And if you have some suggestions, comments, they are welcome. And here is some use case. And the scenarios is to automatic detect attack. If we don't have the policy-based young data model, we need to do this work step by step and rely on the operator's experience. But now we have the young data model. We can generate the young instance and send it to the device, and device implemented, committed to Python script and subscribe the relative data, analyze this data. If it meets the condition, it will execute some specified action to do this detect works of some self-healing works. And what we do, this time we develop an EC photo localization and a self-healing application in the network device, and to provide the auto localization and self-healing such as protect. And here we also develop one network visible application to display the event changing over time. The left hand is the young instance, is the EC script generated by EC models, and the right one is a system review. It shows that the event appears and recovery. Sorry. What we learned? Okay, we collect many useful comments, and we know that the EC young data model can develop and not limited to support automatic photo localization and self-healing, and also collect many other useful valuable use cases such as smart filter and T-Space computing. And we have a great member thanks their comments and contribution, and also we will show our demo in tomorrow's happy hours. And if you are interested in this topic, please join us. Thank you.
Okay, so next up is PII. And then after that, we have I2NSF. Forward and backwards with left and right.
Sure, thank you. Hey folks, I'm Santosh. I'm part of CRAB's information security team. So the topic is on Louder? Okay. So I'm Santosh. I'm part of Grab's information security team, which is a ride-hailing company based in Singapore. I'm sure quite a few of you might have used our company's services to reach the venue from a hotel. So the topic is on personal information identification and logging. So basically, like in today's world, we might have several of the log sources, could be web servers or any of the other applications that might be inadvertently logging PII data. This is one of the challenges that we face in regular like my day-to-day job stuff. So how do we effectively identify and take right actions on PII data? It could be redaction, masking, encryption, or trimming it out from privacy reasons as well as data and compliance reasons. Before we send this data out to any third-party processing, could be external SOC, NOC, or like a vendor who is trying to debug your appliances, right? So you might want to sort of trim that out. So the hackathon plan was to, identify the conventional methods of, like how do they work when you want to sort of parse the logs. Conventional methods like largely regular expression based with not a lot of contextual data, like as opposed to the proposal that we are putting on the table with respect to tagging the data at the source before it is sent out for any sort of processing or parsing. And then probably put this logs out on Logly. So this is the log pipeline that we have, like tried out as part of our proof of concept. So you have a log source, could be like Nginx or any sort of syslog files or whatsoever, and put it for PII data detection. And redaction is one of the use cases that we tried, and we can clearly see that, like you probably would have a lot lower accuracy with the conventional methods, especially the red one indicating at the bottom is showing a hash index, which is actually matching with probably a national IDC, Singapore's NRIC or something is what we were using. That also gets redacted as part of this. So, yeah. So what we have learned is, like regular expression-based detection will induce false positives in our logging analysis as opposed to tagging. So this is what it is. Thank you.
Okay, so I2NSF is next. And then on deck is MUD.
Okay, thank you, Charles. This is Paul Jung from SKKU. So this is the 10th consecutive I2NSF hackathon. Yeah, so over 3 years, we work for I2NSF. So previously, we demonstrated the major interfaces, such as registration interface, consumer-facing, and network security function, NSF-facing. Also, we can demonstrate the security file generator. So this time, we want to demonstrate NSF, the monitoring. So this is not complete yet. We are keep going for next year Vancouver meeting. Yeah. So we used the open source, especially CompD will be used, especially the notification feature will be used for monitoring. Okay. So this is the hackathon project. So we have so collaborator and also student and also the newcomers, the 2 persons joined. So the right hand side we have some information for this hackathon. So this is our I2NSF framework. The left hand side, our goal is to provide intent-based security service. Right hand side, we implemented using on top of NFV and also SDN technology based on OpenDL Lite and also OpenStack. So this time we try to implement I2NSF NSF monitoring, so ongoing work. So this is our basic draft. Okay, so I am editor for this draft. We based on our hackathon experience, we will revise this draft. So we learned how to implement. We got some direction of implementation of I2NSF NSF monitoring. So this is the last piece of data model in our working group. Oh, thank you. Yeah.
Okay, so we have MUD, and then after MUD will be BMP. Okay, left and right.
Okay. Hi, everybody. So we had a slightly smaller table than we did last time. This time, we were planning to do a little bit of an improvement on the MUD visualizer. We actually were going to do a visualization of one particular device called the CCOM recorder. Brian showed up to implement MUD and GRASP, and I was doing some debugging on an internal implementation, and then the folks at CCOM have been looking to develop a model to use MUD for to actually make devices accessible and in a scalable fashion, such the device doesn't have to implement a lot of mechanism. So a lot of this got done. Turns out Brian didn't need to work too hard at this. He got the initial work going in about 30 minutes. We still have some signature work to do. I'll talk about that. Savio from the Federal Institute of Brazil built out some capabilities in the visualizer. If you haven't seen the visualizer, it's pretty cool. You can actually visualize MUD files and see what sort of access a device will get. I did my debugging. I have more debugging to do. We actually did test the device and were able to visualize it. We did some initial modifications for the MUD manager for parsing the file extension. This is a little view of Brian's work that he's done with grasp.py. He's not yet comfortable pushing this into a pip repository, given that he has a couple more things he wants to do, and we really want to bind it to one of the open source MUD manager implementations. Here's like an approval flow that I've been working on, such that one of the key things that we have for network administrators, we got to make it simple for them to understand what's on their network and have a simple approval flow. So this is what we're working on. We learned a fair amount, actually, the first of which is that autonomic computing, one of the things we said was that autonomic computing needs to give some thought to ad hoc authorization models in terms of what devices can talk. We reinforced that MUD is not meant for device configuration, but network configuration. Individualized device. It's not meant for device identity. Open source versioning management is still a pain. Everybody still knows this. And the Python APIs really need a little bit of help regarding verification and CMS. And here's the people who are involved. There's an updated version of this presentation that has a nice picture and correct spelling in some places. So thanks very much, and see you in the next hackathon.
Okay. So next up is BMP, and then after that we have AMBI. Is that what that was? Okay, BMP. Use left and right to go forward and back.
Perfect. Hi, everybody. I'm Thomas from the BGP monitoring protocol, the GROW working group. And what we did is doing some interoperability testing between data collection and routers, focusing on the route monitoring and peer-up, peer-down message types, which we have from the BMP local RIP and adjacency RIP out. And we're using the newly Wireshark BMP dissector and the updated PMSCCT. This is our testing topology, just 3 MPLS PE routers and data collection. Below URL, if you have a BMP router, which is implemented these two new drafts, you can access this website and send over the internet the BMP messages to us, and can have a look how they look like. We identified some gaps, namely regarding local originated routes in the BMP local RIP. It seems that RFC 4271 doesn't really specify what the next hop attribute should look like. We take that to the GROW working group. Another thing which we identified was regarding the peer-up messages when in adjacency RIP out, pre and post policy configuration was applied, depending on implementation, either one or multiple messages were sent. So, and this ambiguity meant some hiccups on the data collection side and on the BMPD sector. We take that as well to the working groups and see how other vendors implemented that. And yeah, the good thing was lab environment was working. And the bad thing, the test took longer than expected. So next time we're going to do in 107, we want to improve our testing and also add now these additional 3 drafts, which are building up on the current one, which we tested this time. Thanks a lot. And these are all hackathon new timers. Thanks.
Okay, fantastic. Okay, AMBI, you guys are next. And after that, we have Swift. Whoa. Left and right. Okay, forward. Sure.
Hi, I'm Max. Hi, I'm Max from TAPS and AMBI, which are closely related, this hackathon. So some of us worked on TAPS, which is like a replacement for sockets. Basically, we have been here before. Yeah, those are the drafts we had interactions with. And then we also tried to work on AMBI, which is a new draft by Jake. So what did we get done? In TAPS, we managed to implement endpoint racing, which is neat. We've had between the hackathons, we implemented protocol racing. So now we have endpoint racing and protocol racing, and are also working on local endpoint racing. There have been a lot of fixes for TAPS during the hackathon, and we found some new interesting interactions and issues for framers, which we are going to take to the working group. Then for AMBI, we implemented the first draft implementation. We created the first draft implementation of the protocol, and that was also the first time our TAPS implementation in Python really got used. So we wrote a real framer for the first time and stuff like that. Yeah, that's basically it. That's us and the relevant Git repos.
Okay, so Swift, and then we have pluggable transports after this. So yours, left and right.
Thank you. Hello, everybody. So my name is Vincent. We have been working on the sliding window FEC codec, whose goal, made a mistake. Yeah. Whose goal is to design an open source FEC codec for recovering from packet losses and reduce latency compared to traditional read-Solomon, for instance, block codes. There are strong relationships with the Coding for Efficient Network Communication research group, and we have been working on also on specification of the RLC codec for that, source code for that, which is almost published as RFC 8681. It's a matter of days. So the goal of the hackathon, as I said, is to design this reference open source free codec, and also to challenge generic API internet draft that explains how to use such codecs. What we've been working on this time is to essentially the decoder side, which is the complex part of a codec. This is where you have to manage and do linear system decoding using some kind of Gaussian elimination stuff. So we took advantage of an existing library for doing that, but this library was designed for different contexts with different logic. And so this is complex to align this library with what we are doing here. So this is basically what we've been doing, thanks to Cedric and Umeima. And we also identified an issue in the generic API internet draft, so that's right. We continue working on the Python wrapper as well as the testing C application. So Small team, 3 people, including myself, Cedric, and Umeima. If you're interested, then there is the GitHub repository, and you can also attend our research group meeting on Thursday afternoon. Thank you.
Okay, so pluggable transports, and after that is JMap for Gmail.
Left and right arrow, right?
Yeah.
Hi, everybody. We work in the area of traffic obfuscation for internet freedom and human rights, and we've worked for a couple of years now on an application level technology to help us do that, to defeat deep packet inspection. The idea of pluggable comes from the fact that it's hard to keep the internet open, and the half-life of these technologies is pretty short. And one of the reasons to be talking about this particular topic of usability today is that these things do change quickly enough that it's hard to keep users informed and hard to give users a new way, an understandable way to sort of stay in the game. So we needed to set up create a development environment for us to look at some of the usability issues and the problems we face. And so we set up this Marionette, which is a Go language implementation of something called of a finite state machine that does format transforming encryption, so we can make one kind of traffic look like another kind of traffic. And this gives us many ways to do that. So it's a good environment that has many options for the user to select, all of which are completely opaque if you're just a regular user and you need to get something done. So we want to understand how to, what the limitations of the current model, this Marionette project are, along with what the global issues are that users face, and can we put these things together to give ourselves a good development model for looking at user experience and making some claims about future user experience. This is how the idea of pluggable transports works overall. Here it is in Marionette, where you have a client that is locally hosted on your device that helps you select a format transforming encryption mode that then is collected by a server, which itself links to your application server. So there's a number of things in here in our current model. They're fixed and static, and they need to get a little bit more dynamic. So we have to look at how do we bootstrap the client properly? How does an application configure itself to use that proxy? And how do you select what kind of transform and what kind of technology, pluggable transport technology you want to use? And also, which server do you select that'll implement that technology in the way you need? So I'd like to thank the team at Marionette who did this environment based on some university research that was done first in Python, and then another team implemented this in Go. Our sponsor is Internews, and we thank IETF for giving us a chance to talk. There's a lot more on pluggable transports at pluggabletransports.info, and we have an internet draft on it also in the usual place. Thank you very, very much.
Okay, and thank you. All right, so next up we have a JMap for Gmail, and after that is the WebRTC. Okay, yep, left and right.
Hey everybody, I'm Seth. Can I just get a quick show of hands of who uses Gmail regularly? That is a lot of people. Hi, I'm Seth. This is Neil from Fastmail.
Hi.
So Neil's worked for the last good while to make a beautiful new application protocol for email clients to be able to work effectively, because IMAP is terrible, honestly. Unfortunately, all of the people in the room here, which is like about 2/3 of people who use Gmail today, can't take advantage of the beautiful new JMap API. And as a result, you have awful loading bars when Gmail loads, and you don't have a lot of options because third-party email clients need to implement email functionality specific for Gmail, or they use IMAP, both of which are vaguely terrible. So, so we thought, well, wouldn't it be great if we had some sort of map from Gmail's API? Gmail has decent APIs. Gmail has an API, yeah. If we map Gmail's API across to JMap, so that way, if anyone wants to build a nice new modern email client, you'll be able to do so easily, and it'll work well. So we did, and this is a little JMAP web client made, which Neil worked on.
Yeah, so we already had this demo JMAP web client, which is open source. This is on GitHub, and we just thought, let's see if we can get that to talk to Gmail. So we quickly coded up this kind of translation layer in the middle, and it vaguely works. And you can list stuff.
Yeah, you can browse your email. So that's what we've spent the weekend doing. And JMAP, if anyone's curious to look at the slides, is actually quite beautiful. You can do these kind of recursive RPC queries. Unfortunately, Gmail's API is less beautiful. Yeah, Gmail's API is kind of awkward and slow, and we kept running into rate limiting issues. We quietly suspect that Gmail doesn't actually use their own API to build their own email clients, and it sort of hasn't been exercised. It'd be really great if anyone is interested, come chat to us. If anyone knows people on the Gmail team, or it'd be really great if Gmail implemented JMAP, and that way we could have all of this stuff working well. So yeah, if you're interested, there's all this stuff's up on GitHub. Although unfortunately, as we said, it's all very proof of concept, and really be great if we could throw up a website which was JMAP with Gmail already working, but it's really slow, and after you refresh it a couple times, it starts taking over a minute to load just because of the rate limiting.
Yeah, they suffer heavily. But come and find us afterwards if you want to see a live demo, and we'll show you something.
So yeah, thank you.
Thank you.
Okay. So I believe next was WebRTC. And then after that, we have TEEP. Okay, left and right.
Thanks. Hey guys, so the RTC Web Group was officially closed last year in Bangkok. So it's been a year that officially the work is done, and of course there's a lot of bug left. So we're coming to the hackathon to go deep into the stack and clean the last remaining stuff. We were not as many people this time as usual in Asia that we were in Europe and so on, but we still had some interesting program. So we had Apple, Intel, and a few other coming today to try to bring a new codec in the RTP part of the stack. AV1, even though it's done at our media, it touches RTP, which is done at IETF. So we wanted also to share the copies and look at how we can make it better, and so on and so forth. Eventually, we got a few bugs actually addressed with patch pending review in different GitHub repository that touch on the stack. And we think we made progress into sharing some tools that are going to make bandwidth estimation and congestion control easier to debug and visualize across different groups, whether it is the IVT core that takes care of the RTP protocol, or RMCAT, which take care, specifically of the congestion control. So globally, less bugs addressed, but a lot of very interesting discussion that should lead into shared tools and shared development for the next IETF in Vancouver. All right, so the usual suspects, plus a few first-timer. Intel joined us for the first time. Thanks and welcome. I hope it's going to be good enough to make them come back and participate. We were certainly happy to have yet another implementer providing feedback for the specification, and another company based focusing on security and encryption that we wish is going to join us again. Well, thanks.
Okay. TEEP is next, and then MDT. Okay, left and right, forward and backwards.
Thank you. This is TEEP. 3 minutes talk. Doesn't mean I have to talk 3 minutes, just going through slides. Great team, slightly misspelling. And what we planned, yes, evaluating the draft, which originally started from ORTRP without a version, and then highly modified to have a TEEP proposal. And we brought a few implementation to TAM, which works as a server, and the device to the different kind of device. And what got done is all pictures, so I don't have to type on the slides. So on the table, this is UI on the TAM. is able to upload the TA through here from Isobe-san's tab, and this is the device running on ARM Opti, and hacking and debugging and many things didn't work. And finally, trusted application was able to install on the TE. And what we learned is many things. It's written in the slides, but honestly, for the implementation, it's long away. Dave's tabs and devices pretty much implemented, but we need the strategy how to make it as a probably in the future of the reference implementation. And that's the wrap up. But before finishing it, this implementation requires a lot of different kind of knowledge. TE, how does it work in different kind of CPU, and JSON, CBOR, and HTTP stack all have to be working perfectly to implement on something on top of it, and how it needs the knowledge of how the device boots. So yes, it's a lot of work. Yes, thank you.
Okay, so MDT, and after that we have SSH HTTP 451. And forward and backward using those two.
This one. All right. Hello everyone, I'm Ran from Huawei. Our project is use young data node tag to filter different discrete categories of young data nodes within young modules, and provide consistent representation and reporting for the same category of young data nodes. We have two related drafts. Actually, the existing young push telemetry provides a mechanism to select and subscribe to operational data objects based on the selection filter. But there is no document to discuss how the selection filter can be specified. To address this issue, we introduced the self-explanation conception, which can be interpreted as instruction on the data node selection principles. So with the self-explanation information, with the self-explanation information, that the netconf clients can select which type of the objects are of interest. For example, to extract the features from the management data objects, such as CPU usage. We develop a running code and deployed it in the telemetry collector and provides a module data node, automatic tagging, automatic learning, and automatic subscription mechanisms. The left figure is our tag model. We call it the OPM model, the O for object type. For example, the interface is an object type, and P for property. The interface name we call it is a property, and M for matrix. The CPU usage or the receive or the send bytes is a matrix. The right finger is how we realize our OPM model in our demo. You can see we collect the CPU usage from the two devices. Generally say, without any pre-configuration, the monitoring data can be collected and displayed, can be collected automatically and displayed on the GUI. Here are our results. We imported our collected data to Influx DB as a data source, and we process and analyze the telemetry characteristic data using Grafana. Both the two softwares are open source. From the project, we better understand the key value of the telemetry tagging, and we found it is important to have more developers to implement it and more service providers to deploy it. And here are our team members. Thanks very much.
Okay. So next up, we have SSH, HTTP, and after that, we have Coin RG. Okay, left and right. Yeah.
Test. Okay. So thank you very much. It's a pleasure to be here among all of you. So I'm just presenting for the team from Mauritius. So the plan was to get some work done in TLS 1.3 for some open source packages. Big plan was to get some work done on SSH, mostly XMSS, which is a post-quantum signature. And it was also on our plan to finish the HTTP 451 Drupal module, which was taking forever. So what got done, HTTP 451, the final fixes for Drupal, but the upstream maintainers requested. TLS 1.3 support for an open source project known as Check Firewall. Loads of XMSS and SSHFP support added to a bunch of tools. So quite a few of them were relying on SSH and just weren't updated since OpenSSH came out with XMSS. One of those tools is big tool is Paramico because it's used as the library for Ansible. So the idea would be to at least have Ansible eventually be able to do some of that stuff. So what we learned, we are just really at the beginning in terms of post-quantum cryptography. Like we've got feedback from the Kernel working group, and the chairs of the Kernel working group are actually asking me to stop sending more drafts to the working group. So we're still, it's very new, and I think we're going to be busy next year with more of this kind of work. The people who did it from Mauritius are actually quite young, between 15 years old till 19 years old. So just a picture of the group, and thanks to Rogers Capital for hosting the event in Mauritius. And those are the list of team members. So again, thank you very much.
All right. So where are we here? Here for CoinRG, and then after that is, was that C4? And these two, forward, backward.
Hi, I'm Marie. I'm representing the best table for computing in a network. We're a proposed research group, but we're trying to do things. We're about data plane programming and adding computation in the network. So our original problem that we had started addressing at our first hackathon in Montreal was to do packet filtering. And we started with that as an idea. We had tons of inputs. Actually, there's a big p4.org that has a ton of templates and all kinds of things for us to get going, and virtual machine. And we had a great participant, Michel, who, because of his own work, had also a lot of tools to get people getting going. We're still at a set of individual projects because our team, we don't really have a team. We have a bunch of people getting together and trying to have fun. But in the future work for the next hackathon, we intend to have a project that will keep everybody together, and we intend to have that defined by the group. So what got done? Obviously, we had a lot of tutorials for people like me and others who don't really know what P4 is about, or not enough. We had Michel, who continued his work on service function chaining, and he had great improvement on his code, so we were very proud. There was just for fun, in Coin, we address a lot of industrial networking issues, and so we had Koi, who actually designed something to do packet filtering for sensor networks, where you actually can define what a packet and how a packet is treated based on the measurements from a sensor. We also had Aris, who started looking at some BGP origin validation. They hit a snafu. They figured out that P4 wasn't good enough for that, and so they took an alternate route. We also had Luke, who helped them, and Luke at one point also figured out that the limitations of P4 were validating some of the aspects that we have in the working group, that we want to use the P4 and the data plane processing to do very basic packet filtering, and we have another device or another processor to do more advanced computations. What we learned that from the Delta from last time, we're doing much better. There's much more people who know about this field and much people who know about the language. We agreed that we should agree on a version of P4 before the meeting would help. We could do that at interim meetings, decide what type of setup we want to have. Bringing a VM on a USB would be great. And by the way, there should be more poster boards with pens and paper because it's fantastic to communicate with the people around your table and not just the people online on Slack. And this is the fantastic team. We had actually all the star people are new stars, the great people. Actually, I think I would like our 2 local people from Singapore to stand up because we had 2 people from the local community who found us, which I think was amazing. And I'm done, and join us Friday. Thank you.
Okay, great. So next up, we have C4, and then BMWG after that. Left and right. You have to go forward.
Okay. Hello. Let me summarize this 4 project. So this project is related to IGN Research Group, and C4 is open source software platform enabling CCN communication, which is compliant with these 2 RFCs. The main objective of this project is to enhance C4 functionalities in the context of the 2 proposed draft, CCN info and network coding for CCN NDM. So more precisely, in this hackathon, we implemented 2 C4 functions. One is in network cache controller using CCN info, which can enable some operator to check out in-network cache condition and configure which data packets should be cached. And the second is a content producer application called Compably, which can utilize network coding in the context of CCN communications. As our achievement, we built and tested the basic plugin modules related to the 2 functions. And regarding lessons we got, we need to make more feasible and flexible naming scheme and deal with interest packet loss to improve the performance of these functions. Here are the team members, and we can get more C4 information and the source code from this URL. Thank you.
Okay, so next up, we got the BMWG, and then after that, we have the measurements team. Left and right.
Hello, everyone. My name is KJ from Sungshin University in Korea. And in this hackathon, so we try to verifying the words of our draft in the BMWG containerized infrastructure benchmarking. So for that draft, we wrote that the CPU allocation, the technology for this these days is not guaranteed to the deterministic results. So we want to verifying this to use some the tools. So the first is the native Kubernetes CPU scheduler, and then second is the comparing with CPU pinning technology using the CMK by Intel. So we want to allocating same number of CPU pod and measuring the throughput and the latency to analyze the impact of the network performance of the container itself. So this is the system. So we have 2 physical server in the remote site, and then one server we deploy the T-Rex on the bare metal, and then on the container node, so we use the DPDK and then Contiv VPP CNI plugin for networking. And then for CPU binding, we use CMK and then Kubernetes native CPU scheduler. But unfortunately, we couldn't get the expected result yet because so many issues in there for configuring and installing and then set up all the stuff. So, some part of the hardware and OS and NIC dependencies. And then the main, our struggling point is that some networking error like the UDP and the Ethernet checksum error. So since that the VPP is a little invisible to the user, so we are struggling to find or figure out what is the problem in there. So and then trying to solve problem as soon as possible. And then after we made it and or share to result to the BMWG. And nevertheless, we learned such different things, and the difference between the vSwitch and benchmarking, switch benchmarking, and then network function itself. So we thought that, firstly, we thought that just forwarding from switches to the container, but there have so many, the configuration is needed. And then on the other end, we learned more than the understanding for technology and then configurations and all the options we tried. And then, one more thing is the TX power consumption. So our remote site server was shut down during the hackathon for a while, or when running TX with 100% CPU usage. So this is our team member. Yeah, and thank you very much.
Okay. So what do we have next? Measurements. And then we have, after that, LP-WAN. And then I'll go back and get the ones that we missed earlier.
Thank you, Charles.
Right, go for it.
Yeah. Okay. Hi, I'm Mal Morton, and I was working with Len Chavatone remotely on our measurement project. And here it is. We talked a bit about this in Montreal. We've been working on an internet draft now. We're into the third version of maximum IP layer capacity metric and methods of measurement. And it's a UDP-based method. At the IETF, we're trying to gain experience with really challenging access. 1 gigabit per second with lots of users that won't go away. That's you guys. So we compared that with TCP cubic this time. Last time we compared it with Ookla's system, which is also TCP based. And we run the test, we iterate the measurement parameters, and do it again. So we were also going to examine the crossover with the benchmarking project that you just heard about, but we'll have to wait for later in the week. So here's what got done this time. Looking over here at the right, we had our measurement system implemented in this nice little PC, mini PC system. So we're able to run that bare metal. And we also had a Google Cloud VM located right here in Singapore, less than 4 milliseconds away. And it was still 15 to 18 hops. The measurement system sends traffic in one direction and it gets feedback in the other direction. So it actually makes adjustments very quickly. And we use the UDP and iPerf 3.6 clients and servers to do that. You can see on the right is the I guess on the right-hand side of the graph is the percentage delivery for packets that we were able to measure using the UDP system. You can't get that kind of information readily from a TCP measurement or the delay variation very easily as well. What we've got here, we're measuring a 1 gigabit per second bottleneck somewhere between us and our server. And our UDP measurements in blue there are pretty close to theoretical. The lowest one I've plotted here is 998 megabits per second when corrected for Ethernet header and one VLAN tag. The other ones are actually higher, and the last one there had a loss ratio of practically nothing. So, and then the 3 TCPs are not doing so good. So let's see here, 23 seconds. Okay, so we learned a lot. Today testing was really messy, so don't test on Sunday. Mini PC was good, a good bare metal platform. We need to do better load adjustment. The search algorithm uses loss and delay. We need to have a better threshold for loss. And we got some actions for the existing draft and so forth. Yep, you and me are synchronized. So we'll try to do that later with the, keep going. With the benchmarking group this week.
All right, thanks, Al. Okay, next up, after measurement, I forgot. Oh, the LPWAN, yep. You go, and left and right for forward, backward.
Thank you. Hello, everybody. Since we are getting to the end of this session, I decided to put the last slide first. So here's the project repo and the team picture. We had a dozen contributors this time, quite a big team compared to the other times. The usual suspects, the draft authors, and some are good software developers. We had Soichi from Japan, who usually attends remotely, who flew in at his own expenses just to be with us this time. So thank you so much, Soichi. We had Olivier, newcomer to the IETF and hackathon, who brought his expertise as well, and one remote participant from Chile. So this is SHIC, the static context header compression and fragmentation, to be used over low power wireless wide area networks. We have a couple of drafts. The first one has passed ISG review, and is we want to implement an open source implementation for that. The goals were, for those who have seen this presentation before, last time we integrated the fragmentation and compression codes, and so this is done. And now we wanted to clean up the repo. We had some remnants from the old structure. And so this has been done. We've improved the documentation, make it easier for newcomers to understand how the code works and how to get started. And also to improve the functionality, because the draft has a lot of features in it, and we hadn't implemented everything. And so thanks to Olivier, we set up the Travis continuous integration, so we get more professional at the way our software is developed. So what we learned is, of course, a better shared understanding of the specs between everybody around the table. We spotted, obviously, a few issues in the implementation. We even tried running the test code on an embedded device itself. And yes, it fails. It's a bit too big with the test environment, so we need to split the code, but that gives us some way forward. And of course, we need more test automation. We also spotted a missing element in the data model, which is another draft that we work on at the working group. And also, we think we are ready for interop. We know of 2 other implementations which are not open source, and we'll be probably doing an interop at the next hackathon. That's it. Thank you.
Thank you. Okay, so yeah, now as promised, we're going to go back and try to pick up some of the ones we missed from before, starting with DNS. Okay. DNS. There we go. And let's see. Yeah, so left and right for forward, backward, and it's all.
Thank you very much. So, all right, welcome. So these are the results of the DNS table. Good. So as usual in the DNS, at the DNS table, we don't have one single plan. We have a group of individuals with their own plans, and we work together and we talk a lot. But we have a number of themes. The privacy, DNS privacy, of course, It's important in the past years. DNS protocol improvements, container, DNS and service provisioning, and some miscellaneous, some measurements. Good. DNS privacy. Continued work on DNS over TLS, but in the previous years we worked from the stub, from the client to the resolver. New work in the DNS privacy, deprive working group is from the resolver to the authoritative, A-dot also called. So there was a hack, kind of proof of concept implementation inbound, how to implement that, using subnet specification and a host name to validate, to have an authenticated TLS connection to an authoritative name server. How to bootstrap this list is something the deprive working group has to work on. So if you have ideas in this room, you are welcome to join the discussion on deprive working group Friday morning. DNS over HTTPS, the Bind 9 has made a design for implementing DOH in Bind 9. And with that, we have in 2020 DOH in Bind 9, Unbound, in not resolver, and in Power DNS dist. So we have 4 open source implementation of DOH, which is good. So there's a choice, there's different options for deployment. Also a proof of concept implementation of DNS over HTTP3, quick. Work in progress based on 1 minute. Thanks, Ankish. Some protocol improvements. Cookies, DNS server cookies. Why should we care about DNS server? It's a way to mitigate DDoS. Spoofed addresses, you can filter them out. So DNS server cookies, we did have a specification. It wasn't very interoperable. You could make different implementation decisions with the BIS specification. We solved that. We have 3-4 implementations that are interoperable. And extended error, well, skip that. Another draft working on. Service provisioning, I want to mention that. It's important. It's something we are thinking in the DNS community, thinking a lot about how to solve this problem. In the last IETF, there was a new draft. We did an implementation of that draft. It was called HTTP SVC at that time. It has been renamed to SVCB, Service Binding. We updated implementation and got some feedback. Thank you.
Okay. So the order and who's next is a little harder for me to figure out now, just because I'm going to basically go back and I'm going to pick up all the projects, just go from top to bottom and anything we missed. I believe we've done all of these, and the next one I think that we haven't done is Caport. If you see yourself in the list and I skipped you, and let me know, we'll go back and get you. So Caport, who is presenting that one? Great. Okay, here we go. And so left and right, go forward.
Thank you. Hi, everyone. So I'm Remy. I was working here also with Selva and Heng. We're sitting over there on the captive portal, some captive portal proof of concept for the Caport working group. For people who are not familiar with the work, they're basically the first objective of what the Caport API that's discussed in the working group is first to make captive portals less bad, because they're like very often really bad, and because for example, detecting that there's a portal is really tricky. But apart from that, it also enables a number of use cases. For example, knowing how much time you have left on the portal if it's limited, or like knowing how much data you have left. Also having a way for you to know if you're still connected or not, if like the network just disconnected you and you have no idea about it. Generally, it's not great. And also it enables use cases such as, having in-flight entertainment in the plane without having internet, anything like the schedules, timetables if you're at the IETF, knowing like where your meeting is, or like the train at the train station, stuff like that. So general flow of the demo we built was first to discover the API endpoint for that API. So from the draft, it could be over DHCP, IPv6 arrays, or the link relation header as a backup. We implemented DHCP. Then basically the demo probes the endpoint to detect if a portal is open or closed, get the session information, and show info in a notification. So this is a demo that was implemented on an Android phone with open source IOSP. And on the access point side, so we have a team from a Google station who is here today, who provided one implementation that they have, for this captive portal API. So yeah, and they provide, whether the client is captive or not, they provide a captive portal page, how much time is left, and also a URL for information, which happens to be the IETF information page. So here's what the demo is. I can't show you because on the screen it will be way too small, but here's what it is. Basically, you connect to a Wi-Fi, tells you tap here to sign in, the usual thing. When you open the portal, which is, in this case, the Google Station provided portal, you can log in, you get free Wi-Fi, and then you get this notification that tells tap to manage. And when you tap on this, you can get, information about this access point, which is basically the IETF info today. And that's it. Contacts here for me for Android for GStation. You have Salva and Heng, and the code is on IOSP, open source.
Thank you much. Next up, if I remember right, is iFit. And hold on. Where'd it go? There it is. Do we have someone to present iFit? Okay, great. And left and right to go forward.
Left to right. Okay. Hello, everyone. I'm Tian Zhou from Huawei, and we worked on the institute flow information telemetry. The iFit provide a reference framework to acquire data about a packet on its forwarding path. But when we deploy it in large area network, there are several challenges for deployment in carrier network. Firstly, the performance, the forwarding impact due to the packet processing, and the bandwidth and the server overload due to export data. And there are some other challenges, for example, the limited data flexibility and extensibility, and the deployment issues, and encapsulations and the tunnels, and the primitive models API for telemetry applications. So we are considering several key components to address the challenges, including the smart flow selection, the export data reduction, the encapsulation and the tunnel modes, and the dynamic network probe, and on-demand technical integration. This is what we implemented last time in Montreal, and we implemented the postcard-based telemetry and achieve several use cases, including the delay monitoring for node, link, and end-to-end. And we also implement the packet loss monitoring and the path tracking. This time we add two functions. One is the sketch-guided elephant flow selection. We can dynamically insert the sketch in the device and select the elephant flow for high precision monitoring. And second, the exporting data packing. we can define the number of packets to be bundled and define the time interval to force export. In this way, we can reduce the exporting data. And next time, we are going to attend the hackathon again, and we will use P4 switch to implement and demo this. Thank you.
Okay, next up should be spin dump. There it is. Okay, and left and right.
Hi, we're the quick measurements team working on the spin dump tool. So for this hackathon, we plan for adding some more functionalities to the spin dump tool, which is basically a network latency monitoring tool. So we wanted to implement support for what is called a delay bit. It's an experimental proposal of adding another bit to improve latency measurements. We also wanted to improve our RTT statistics, and we wanted to add more spin bit supports to quick stacks. So what we got done was that we added support for this delay bit, so we can get improved RTT measurements for endpoints that support that one. We also improved the statistics by adding some more statistics like standard deviation of the RTT measurements, and we also implemented some RTT filtering based on that. And we also managed to get spin bit support into the Move Fast Quick Stack from Facebook. The team was me, Marcus Hilar, Jari Arko, Fabio, Mauro, and Ronnie Evan. Thank you.
Let's see, forgot who's next. So Wishy is next. There we go. And left and right to go forward and backward.
Great, thank you. Okay, hello everyone. Here's a report from Wishy, our work on IoT semantic hypermedia interoperability. Our plan for this time was to work on data model convergence and automatic translation, in particular with the 1DM language and tools. Also, we plan to work together with W3C Web of Things. We had a joint meeting this Friday together with them, and they joined here on their Web of Things Plugfest activities. And finally, we plan to work on UP, which is this translation between binary and JSON-based data models. What got done over this weekend, we had a lot of work on the 1DM tools and concepts, in particular doing conversions between 1DM SDF and live with M2M IPSA models. So this is the reverse from what we did on last IETF, where we did from IPSA to 1DM, but we also enhanced that kind of translations. We also have a linter for 1DM models, so you can check the validity of your models. And we worked on a CI in GitHub to actually check real time when you commit new models that they are actually valid. Most of the code for above is already available on GitHub on the link above. We also had very good discussions on architecture, use of semantics, how you can handle dynamic descriptions, and in particular, how you should work on convergence across SDOs on various specifications in this area. On UP, now we have also basic encoding from JSON to binary, so we can go both ways on between JSON-based and binary-based models. And on Web of Things, we have now first version of TD discovery using CoAP-RD. One thing that we agreed to work on going forward is this semantic proxy. So the idea is to go from 1DM descriptions, potentially with use of some RDF, to thing descriptions, and then we could be using something like semantic proxy or a gateway to work between applications and devices from different ecosystems. So if you're interested to work on this topic, you're very welcome to join our ongoing Wishy activities at the Thing2Thing RG. Something we learned, again, of course, we knew about it, that you shouldn't do models and examples by hand. You make a lot of errors there. Good CI helps here. Automated tools are even better. It's not like the tools don't make mistakes, but they make mistakes in a consistent way. So it's usually easier to fix on the flow. Here's our team members. And if you want to learn more about it, you can go to wishy.space or to our IETF hackathon space. And very welcome to join on the ongoing activities. Thank you.
Okay, next up is L4S and then NTS after that. And where is... oh, there it is. Okay, and left and right to go forward and back.
Okay, so this is low loss, low latency, scalable throughput, L4S, from the transport area. It's essentially a transition mechanism from today to a position where everything can just be low latency without having to particularly do anything about it. And we mean really low latency. Links there to existing code and the specs. We had a number of remote people as well today, and also 3 new people, 2 of whom are on site, and 3 remote people who were remote last time. So it's not all bad when you're remote. Some people do it twice. What we got achieved, really 3 projects. The first 2 of those bullets are about testbed. And the first one was one of the new people, getting them to work through the README and check, you know, a fresh set of eyes can do everything without anyone else telling them side information. And also the other one going on the test, another test bed was running TCP Prague versus, well, not so much versus, but coexistence with BBR v2. Which has an L4S transport within it. That's Google's BBR. Well, it's the community one. Ran through full set of tests on that. On Accurate ECN, Ilpo started Saturday on this, looking at the Linux code to prepare it for upstreaming into Linux. So he was getting his head around it all, reviewing the code, and sequencing the patches so that they can go in. Oops, missed that one. Reasonably in order. And they're also a complete remote team working on NS3. Added fast startup, got that running, but still more to do on that. I need a testing framework around it. Updated the dual queue to the spec, although that's still in progress, and added configuration code so that it auto configures when you all the ECN and DCTCP stuff for the NS3 implementation of DCTCP. So we found a few missing steps in the README. Accurate ECN found it's more flexible than it first appears. This was also with the SEE team here. Richard was explaining how that might be added. That was already reported. And NS3 is useful for getting things done.
Okay, next up is NTS, and then who was it? TMRAD, I think. And I think that's it, unless I missed any. All right. Yeah, you guys are, here it is. Awesome. Okay. Getting close. You know the drill, left and right.
So, hi everyone, my name is Christer Weinigel. I work for NetNode in Sweden. So I'm going to talk a bit about NTS. It's security for NTP basically. Okay, sorry. So time is important is basically the message, and I think everybody knows that, so I don't have to come up with a lot of examples. And when it comes to time of the internet, NTP is the protocol that everybody uses. It's been around since 1985. I think it even predates BSD sockets. So NTP is pretty old. NTP does have some security, but it's based on symmetric keys, pre-shared keys, so it doesn't really scale to a lot of users. NTS adds the kind of scaling we need to be able to do secure NTP to everybody. And I must admit, haven't done a lot of progress today, which is in a way good, because we got a lot of things done at earlier hackathons. My first hackathon was in Prague, and I felt that we made a lot of progress at that time. So today, what I've done is really just been working on scripts to verify the functionality of NTS servers. That's because we at NetNode have a NTS servers up and running now, and we intend to keep them up and running. So I'm trying to build tools so that our IT operations department can see if anything fails and quickly correct it. It might be interesting to other people, so I'll try to open source this. I've been also working on how to actually start using NTS in a client, and I've been using NTPsec as an example. And this how-to is supposed to, or I'm going to show how to do it with the NTS servers from Ostfala University. Martin Langer has done those. We have Cloudflare officially said that they have NTS servers that they intend to keep running. I've done an implementation for NetNode, which is a Frankenstein's monster of my Python code and the timestamping from Crony. And NTPsec, they also run a couple of servers. And sort of good news, the NTS draft was submitted for publication on November the 7th. So hopefully this will actually become a standard pretty soon. And not much to say. Today it's been me, Christer Weinigel, and Dieter Siebel, who have been working on NTS. And I'll be at the hack demo tomorrow if anybody has any questions or wants to see anything, has any wonders about NTS. And there's a link to the draft also, if anyone wants to see it. Thank you.
Okay, next up is TMRID. Which was down here at the bottom, PDF.
Right arrow to advance.
Mm-hmm. Okay, I'll make you full screen. Yep, left and right. Go forward.
Thanks. So we're working on a problem that comes from the real physical world. You're at an emergency scene. You see this unmanned aircraft hovering above the building that's on fire, and you want to know whose it is so that you can figure out whether it's like another fire department and has some business being there, or maybe it's the guy that started the fire. So there's another standards development organization, ASTM International, that's been working on this problem for the U.S. Federal Aviation Administration and various other civil aviation authorities in the rest of the world. Problem is, their standard does not provide for information that is immediately actionable and privacy preserving. So we're looking at leveraging some IETF work, mostly related to HIP. We're going to need to update HIP with some new crypto and make it hierarchical. So fundamentally, this is to make the claims that come across one of these remote ID systems trustworthy. So we started early at the New York UAS test site. We did some stuff with DNS lookups. What we were working on today is a Shake 128 based hierarchical hit as a temporary stand-in for a C-Shake based hierarchical hit. Adam got Ubuntu builds working cleanly on recent Ubuntu. We started discussing observer to pilot emergency comms via HIP proxies, back in New York, we flew a Bluetooth broadcast UAS from WhatID of currently standardized flat hit, what we're going to demo here right now. And you here in the room aren't going to be able to see this, but those who are playing along at home, since the camera is right here, will be able to get a better experience. I'm going to start a scan here, and then Adam is going to start broadcasting using his cell phone as a surrogate for an aircraft. And I hope that the Bluetooth range reached it. Did my screen paint? Yes, it did. Those of you who are playing along at home can see that the UAS ID type is a host identity tag, which is not in the ASTM standard, but we're lobbying for it to get added to that standard. We need some more reviewers. We need some interoperability experimenters. Some of the work that was done in HIP a few years ago on an experimental basis really needs maturation. Some of the drafts need maturation. When I say UAS from WhatID roles of WHOIS, I'm really talking about the whole domain registration process, not so much the WHOIS protocol, probably the new RDAP protocol. How are we going to use DNS? Because the privacy preserving aspect is really important. Duly constituted authority needs to know who's flying that thing so we can tell them to get the heck out of that airspace because the building's on fire underneath them or whatever. But the little old lady next door who just doesn't like the buzzing sound in the neighbor's backyard shouldn't be able to use this as a pilot harassment tool. So the new IETF work will be mostly in the HIP working group, but we're also going to need to do some coordination with other standards development organizations, including ASTM, the International Civil Aviation Organization, and the Radio Technical Commission for Aviation. And so all the team members are noobs except for Bob Moskowitz. And please join us at our BOF Tuesday morning. Thank you.
So we have a presentation on NetConf Yang managed tester that I missed, and then we'll have Quick after that. Whoop. So left and right, go forward and back.
Okay, so our goal was to implement the RFC 2544 tests in a simple command line tool that connects to the devices part of the test setup over NetConf. And those devices had the Yang model. So we have a draft that describes this solution, which is described by this diagram here. And the execution of the test should be as simple as running a command line, providing a configuration based on Yang models, mainly the topology IETF model, augmented with data about connecting and specifying what kind of parameters the test should actually take into account when executing. So this, there are many different RFC 2544 implementations, but they usually involve graphical interaction, which is not so easy to reproduce without there is no model. So this is this was the goal of the test. So to do a RFC 2544, you need the hardware to actually execute it correctly. And then we had to make hardware for that. So we have two testers. One is a proprietary tester on the bottom, and the other one is the open source, open hardware tester, which is running Debian. Both of them are running Debian and UMO 123 NetConf D server. The middle one is an open flow cheap switch that we used as a device under test. And we put NetConf D wrapper on top of that so that we can have a transactional model. And that's about it. Thank you.
Okay, Quick.
Good afternoon. The usual suspects were in the back corner there, interrupting their quick implementations. I think we had 7 clients and 11 servers actually participating. That's a little worse than usual. A couple reasons for that. Number one, I think we had lower attendance here in Singapore than we did in Montreal and some others. And secondly, Draft 24 dropped only a couple weeks ago when I think we had several implementations that weren't quite caught up yet. Nevertheless, the story is fairly similar. A lot of the basic functionality we have pretty strong interop on, even though some of the details are changing. We have a few implementations that are doing some of the advanced IP address migration stuff and some of the more advanced HTTP3 features like push and so on, but probably not as many as we would like. Overall, I think things are moving forward. A lot of the production implementations are maybe don't quite have all the interoperability check boxes that some of the the for fun implementations are having, but they're getting there and they're getting closer to something we can actually deploy. Any questions? That's all I got. Thanks.
Okay, any presentations I missed? Okay, one thing I forgot to mention earlier, if some of the teams, if you want your like a team photo taken or something, we have our friendly photographer who will hang around for a bit afterwards, and you're welcome to stick around, let them know you want to get a team photo taken. Several of you mentioned that you plan to present at the Hack Demo Happy Hour tomorrow. That is what, from 6:10 to 7:40 p.m. Would love to see you there. If you do plan to do that, the sooner you sign up, the easier it is for us to plan and manage the space. And we have a cutoff time at noon tomorrow. If you sign up after noon, we'll try to accommodate you, but I can't promise that we will, especially if we have a lot of teams presenting. The Code Lounge will be here, kind of this half of the room. So I know some of you said we didn't get a chance to finish everything, or we have other things we want to continue working on. You're welcome to use that space if it's helpful. You can also schedule time. There's a page for the Code Lounge. You'll find it in the Hackathon wiki. And so you can sign up there, and welcome you to do that. Had a thought, next time I think what we're going to do is we'll give a time penalty to anyone who doesn't get their slides in, like we'll 1 less minute or maybe 1 more minute if you do get your slides in time, and a bit of an incentive there. Other than that, I think we're done. Thank you all for coming here early, spending your weekend with us. I hope you got a lot of value out of the hackathon. I think I've certainly seen a great sort of impact that the hackathon's had on what's happening in the working groups. Please do bring back what you learned into your working group. Feel free to upload more like your presentations. If you have things you want to add to them, you're free to do that even after the hackathon ends. That's all good, because that's a great resource. And we have MeetEcho recording all this, so we'll have that too in case you want a recording of your presentation. Any questions, comments, feedback? Well, I think we have to thank you. Yes. Okay, well, thanks. I'll accept that. All right. Well, thank you all, and we'll try to make sure we have as big a space and in Vancouver, and hopefully even more. Like all of you show up and tell your friends and bring them along too. So thank you very much. Enjoy the rest of the IETF week.
Thank you. Thank you so much for organizing. Question for tomorrow. Is there a chance we can keep the technical in the room for tomorrow? So we can reuse some of the drawings or use them as posters, something like that.
I can't guarantee that we will keep the exact same board, but maybe would it work if you tear those sheets off and then you can take them back up or whatever tomorrow? I'm not sure exactly what the setup's going to be. I tried to get at least one of these poster boards for each team, so we should have something for you to